Hello, and welcome to the second of these AIS developer videos. The subject today is going to be packet sniffing, how we do packet sniffing and how we use it in the device monitoring application. Now, I understand that one of you was having trouble listening to the audio. The audio in all of these videos, including the first one, is at the very maximum that it is possible on any video. So these tips are for watching video generally on your computer. Firstly, can you check that the volume control on your laptop is turned up to the maximum? Second thing, if you look on this YouTube video, you should see an icon near the bottom left corner of the window with a speaker on it. Please make sure that the volume control next to this is also turned up to maximum and not on mute. Thirdly, if your laptop really isn't putting out the volume, you could try asking the people around you to be quiet. You can also try plugging in external speakers, and if that doesn't work, then you can try wearing headphones and plug them in. There should be a headphone jack on your laptop. If none of these things work, then you need to get a better computer. I'll now repeat that in text in case you can't hear the audio. Please check you can hear the audio. Check the volume control on your laptop. It should be probably a slider button or a turning pot. Now check the YouTube video. There should be in the bottom left corner an icon of a speaker and a slider beside it. Please make sure that that's switched to maximum, also that it isn't on mute. Okay, if none of those things work, you can try plugging in external speakers. Listen to it in a quieter environment. Finally, you can try plugging in headphones. So, I hope you can hear me now. There is nothing more we can do this end. The volume, as in the first video, is the maximum it can possibly be. It's cleaned up. We're using a professional microphone. I've moved it into shot because I think it was fooling you that it was out of shot last time. Now, let's get to our subject, sniffing packets. This is the first of the level 2 apps. So if you look at my screen now, you'll see I have all of these apps. This is simply the directory from which we check out from Git. We're going to look at the first one, AIS 201 device monitoring, and you will see how the code is arranged. This code arrangement is a requirement of Android Studio. We're using Android Studio for compiling the Java, or at least for packaging the Java code and creating the APK, which requires a certain format, a certain arrangement. So you can see under app, source, main, Java, and then our identifier. And here are this is all of the code that we use in this particular app. Today we're specifically concentrating on packet sniffing. Now, there's a free and powerful tool which is used for packet sniffing on any platform, and that's called TCP dump. I'm on Linux right now, and of course it's installed as a matter of course. So let's see where it's installed. Okay, there it is in the system bin. We can monitor packets on this machine if we have root access, because of course we can't have anybody monitoring all of the packets. That would be a security violation. So let's bring up the code that we use. We use a series of command line options so that we filter in only the packets that we're interested in, and also in the format that is most useful to us. So what we're doing on Android is running TCP dump. As I said, it's a completely open source utility. It's been around almost as long as Linux. Can be used to diagnose any network apps that you happen to write. Today we're using it for packet sniffing. It's a convenient way of doing it. We'll use the same command line that we're using on Android. So I'm just copying this now. And then pasting it in there. Now, there's one other thing you may have noticed I will need, and that's to run as root. And off we go. Now, here you will see it's dumping all packets that go through the network card on this machine, the primary wired network card. If we just take a look at one of these, it's TCP it's capturing TCP packets, UDP packets. So basically anything on the TCP/IP protocol, high level or low level. And with each one of these, there is a standard header at the top, which gives us the some of the routing information, and then there's the actual packet itself, which is understood by the individual application. So the structure of this packet here will change for each application, but the headers remain the same. That's how we do it on Linux, and we do exactly the same on Android. Many versions of Android actually have TCP dump built into the system, so that it's already available when you buy the handset or when you start using it. So yeah, some of them have that. All of the open source ones do. Some of the commercial ones do as well. But we can't rely on every single one having TCP dump. So what we've done is we've compiled it in all the major processor flavors. I'll show you here. So this is ours that we've compiled from the freely available open source. Here it is if you're on an older ARM machine. Most of the devices we support are ARM64. But here are two of the versions. I don't think we have any on MIPS, but you might have some on Intel. So we've compiled the binary and put it into JNI libs to fool the Android Studio to include it in the APK. If we just put TCP dump in there, which is what it's normally called, you'll notice over here, the actual name of the binary is TCP dump by default. If we put that, the APK tools would have stripped it out and would have refused to install it on Android. But luckily they're stupid enough to install, they will install anything that looks like a library. So simply by packaging the binary to look like a library, we've added lib underscore at the front, we've added lib at the front and .so as the extension. Now the tools won't strip it out, they will install it for us, and the only penalty to us is a mild one, which is when we call it using the name libtcpdump.so. It's not a shared library, it's a standard binary, and it accepts command line parameters as usual. These are the command line parameters we use. Line flush, that's just separating the packets into by new line. We wanted hex format. We want the complete timestamp so that we can parse it more easily in our code, because we're not reading the packet ourselves. We have Java code using regular expressions to parse the packets. We don't want the IP addresses converted because we don't know where it's going to get its host names from. So all IPs are in standard format, standard number dot format, and we want to capture both TCP and UDP. So in Java, when we request packets, that's what happens. It starts TCP dump running on a separate thread in the background. Anytime you need to do some kind of functionality like TCP dump, which has to be fast because those packets aren't waiting. They don't wait for anybody. They're in a loop cache. They need to be accessed as fast as possible and parsed as fast as possible. So that's something that Java simply can't do. It is not fast enough. There are also no API calls in Java for accessing any of the information that we need. So TCP dump is written in C and accesses the Linux kernel directly. So all we can do with Java is to start it on a separate thread and then parse the output. You'll find this generally. If you need to do anything which is time critical or any serious processing, you'll need to write it in C or C++ and then call the functions from Java. You can use a library in some cases, not in this case, because you need to have it running its own loop. It needs to be, it can't wait for Java polling in order to capture packets. So we've started TCP dump. I will show you now what it looks like. So let's start the device monitor. Now you can see here there are a number of apps running on this device, and what we're interested today is in the number of packets that are being captured or being generated by the device, by the individual application. So let's look down the list. You notice that the Google app, for example, has sent and received 13K packets and 18K packets. So that's a particular target. But the one that my favorite is Facebook, because it regularly generates lots and lots and lots of small packets, and it doesn't matter what it's doing. You don't even have to log into Facebook for it to generate you a lot of data. So if you're worried about the amount of data that your phone is using, one thing you can do is switch Facebook so that it only works with Wi-Fi, or just uninstall it. But anyway, it's a great source of data for us today, so we're going to select Facebook. This is the summary of what's happened so far, and we'll go straight to packet capture. Now you'll notice that I have a packet capture button on my app. It's not grayed out, and you'll notice at the top it says AIS monitor root. This device has root access. If I used a different device without root access, we would not be able to do packet capturing for the security concerns that I talked about earlier. Let's start the packet capture now. And we'll wait a few seconds for Facebook to generate some new data. The packet capturing is processor intensive and only happens when we request it, so it's not happening in the background. There we see there's a packet come in. We'll wait for a few more. It's being unusually shy today. Okay, there we are, we've got a few packets. It's usually more profuse than this. So you can see them being listed there at the top. It's captured 3 packets so far, you can see that bottom left corner, and let's have a look at one of them now. So we just click on the packet, and you can see that the packet length is 61 bytes, and you can see the hex dump of the packet here. Now, if you were writing an application specifically, for example, to spy on HTML communications or on email or something like that, then you would give your app additional knowledge about the structure of the packets for those specific tasks. For in those cases, HTTP or Simple Mail Transport Protocol (SMTP). Let's look at some other packets. We're getting quite a list here, you'll notice. So Facebook is not at all quiet. Let's look back at the code now. The TCP dump is being run, you can see, as root. And then what we do is we leave the stream running and we intercept the feed from it, which, as you saw on the command line, this is the feed that comes out of it. This is the feed coming out, but we don't see it ourselves. What we do is we have Java capture that, and then we use regular expressions in order to parse it. So what you're looking at now is the formatting code to make this human readable. This is all in device monitoring activity.java. Most of the Java files in this app are simply running the different dialogues, so they're not, the code isn't of great interest, and most of the work is done in the main Java file, which is device monitoring activity.java. Here's where we're parsing. Here's where we're parsing the output. So we've started a thread with TCP dump running, and now we're parsing the output from that on standard out. And every time we get a new line, or a block of lines, because they come in much faster than Java can process them line by line, we run process line, and what that does is it parses out the data. So let's have a look at that now. And here it is. So it's parsed with line or lines from the TCP dump output, and we do the match packet item, which is the regular expression used to split it up into pieces, and then here are the pieces being read. So you can see the date being formatted out, the host from and to, and the port from or to. So what we're parsing out, and you can see it in the headers on the app screen here, we're parsing out the IP address that we're listening on, the IP address that the packet is coming from and to, and the particular port that's being used. We're also parsing out whether it's UDP, IP6, IP version 4 or version 6. We're getting the length of the data, and we write all that into an item, which is then put on the list, which is displayed on the app that you can see right now. So that's our first developer video. It's a simple description of how we do packet capture on Android devices and parse and display that information. And so if you wanted to take it further, if you want to do any application that's spying on a network app, or simply if you're doing development and you're trying to find out what's going right or wrong with your app, this is a great way to do it. Goodbye.